Thank you very much. Thank you for joining us for the first Ocean Nexus webinar. This event is presented by the Nippon Foundation and Ocean Nexus. Nippon Foundation is an international philanthropic organization promoting actions to achieve a society in which all people support one another. I think it's brilliant. As Ocean Nexus, who's organized this event, is a research network of scholars who conducts their research with empathy by employing anti-racist, decolonization, and intersectionality as our analytical lens. As a group, our mission is to establish social equity at the center of ocean governance. My name is Yoshitaka Ota, the director of Ocean Nexus, and I'm a professor at Marine Affairs Department of University of Rhode Island in 4 days. I'm still a professor at the University of Washington. I'm moving soon. Today's webinar features data and digital technology of oceans. We have two speakers from Paul G. Allen School of Computer Science and Engineering in the University of Washington. The first speaker, Dr. Matt Ziegler, is an Ocean Nexus Innovation Fellow. Matt has over 10 years of experience in environmental technology projects like biodiversity informatics, ecosystem modeling, and environmental communication applications. In Ocean Nexus, Matt examines social equity issues at the intersection of artificial intelligence, that's what you're going to hear about it today, conservation technology, and international environmental policy making. We have another distinguished speaker, Professor Richard Anderson. Professor Anderson's research has focused on computing for the developing countries and global health. I mean, I cannot really summarize what Professor Anderson has done it, but notably, I would like to mention, in 2020, Professor Anderson received the ACM Using L. Lawler Award for Humanitarian Contribution within Computer Science and Informatics for his impactful research and work bridging computer science and global health. And now Richard is even crossing towards ocean, which is brilliant. So the format of this webinar is first, Dr. Ziegler will present his work, and then Professor Anderson will discuss on that topic. Then we have time for Q&A. Please write your question at the Q&A section, so we will read them out after the presentation. Now, I'm passing to Dr. Matt Ziegler. Matt, there you go.
All right. So thank you for the introduction, and thanks everyone for coming. So I'm going to first present some slides on designing equitable ocean technology. So let's start with, what is ocean technology and why is this important to talk about right now? So a variety of new emerging technologies are starting to transform ocean governance. One is ocean observation systems, which bring together different technologies like sensors, tracking devices, and satellite remote sensing to monitor changing environmental conditions. Another is vessel monitoring systems for governments to track fishing boats, where there's more and more onboard video surveillance on fishing boats, increasingly using AI. There's a lot of different mobile apps for fishers for things like collecting data for compliance and getting environmental certifications. There's increasingly complex and computationally intensive models for fisheries management. And there is technology for supply chain traceability, just to name some examples. But we know that the spread of computing technology hasn't been fair to everyone. For example, internet access and device ownership haven't been fairly distributed. This map shows how broadband internet is much more easily available in some parts of the world than others, for example. We also saw this during the COVID-19 pandemic, when some people struggled with online education much more than others because they didn't have reliable internet at home. Another well-established problem is discriminatory biases in AI models. The example on this book cover on the left illustrates how racism and misogyny are embedded in AI language models, which they learn from being trained on text from the internet. We see similar problems in visual AI models. For example, in one famous case, the passport application website for New Zealand was rejecting photos of Asian people because it thought their eyes were closed. And in this third example, researchers measured that Amazon's facial recognition product guessed the genders less accurately for Black and brown women, tending to erroneously label them as men. AI model biases are starting to have more real-world impacts on people as they find their way into real products and applications that we interact with. For example, there have been cases of wrongful arrests because of errors in facial recognition. Another example of technological inequities, marginalized groups are disproportionately subjected to electronic surveillance, both online and offline, and often along lines of race, gender, and nationality. Surveillance systems are increasingly incorporating AI also. So, given all these problems, how should we make sure that ocean technology is fair to everyone? We're taking the perspective that for ocean technology to be equitable, it must be anti-inequity. And this intellectual foundation is based on Ibram X. Kendi's work on anti-racism. If you want to learn more about ocean equity, you can check out the Learning Forum on the Ocean Nexus website. So, here are some important questions to consider for designing equitable ocean technology. One, in an ocean technology project, who has decision-making power? Two is who is excluded, either by technology access barriers or by design factors. A third is who benefits from model biases. This is becoming more important with the rise of AI. A fourth is who takes on burdens and risks. In an environmental technology project, these can be anything from extra work for some stakeholders, expenses, security and privacy risks, or reorganizing their institutions around the technology. A fifth one is who benefits from techno-optimism. What do I mean by this? Well, technology is not the solution to every environmental problem, but new technologies tend to bring a lot of hype, excitement, and confusion. And sometimes this technology hype is used by powerful actors for greenwashing or distracting attention away from issues or avoiding regulations. For example, a couple years ago, there was a lot of hype about blockchain bringing unprecedented traceability to fishing supply chains. But years later, we see that blockchain hasn't really delivered on these promises and the impact has been pretty minimal. So who benefited from this? This is just one example of an equity problem stemming from techno-optimism. And importantly, I'm not saying that ocean technology is bad or that we shouldn't do it. I'm saying that these are some conversations that we need to start having in order to do it right. And this list is not exhaustive. And for the rest of this presentation, I'm going to go into more detail and give some examples on 3 of these points. Unfortunately, don't have time for all of them. So first, let's talk about decision-making power in ocean technology projects. So to talk about decision-making power, let's first go into the example of modeling for fisheries management processes. Really complex and computationally intensive models are becoming more and more common in different oceanic management processes. This slide has a couple diagrams just to show you how complex they are. More and more of these models require a lot of computational power. Like now it's pretty common for a model to take something like 2 weeks to run and produce a result on heavy, expensive cloud computing infrastructure. So what is the equity issue with modeling? These ocean management models tend to get used in highly political and contested negotiation processes, and the ever-increasing complexity of these models makes it harder for smaller, less powerful stakeholders to participate. This is important because the models take a certain point of view, like what is modeled and why. Some things are prioritized, other things left out. These choices can be really political, and when the models become so complicated, it has the effect of squeezing out less powerful stakeholders from the process who have less technical capacity for modeling. For some more depth, I'd like to refer you to Angela Abul-Hassani's work, an Ocean Nexus Fellow, on how management procedures built on modeling frameworks can obscure these power imbalances. There are a variety of participatory modeling processes that try to bridge this gap, but in practice, they often fall short because the more powerful actors still keep control of the whole modeling process. So what do we do about this? There are some ways we can partially address this problem with technology changes, like using simpler models to lower the barrier to participation, or by building better interfaces with more interactivity. However, technology changes alone are not enough to fix the core problem of who has the decision-making power. Towards this point, I just want to flash you this diagram from Pedro González Espinosa's recent publication on equitable use of modeling and coral bleaching management, and I will refer you to that paper for a more detailed discussion of equity and models and management. So let's move to the next consideration for designing equitable ocean technologies: who is excluded? There are a few different ways that relying on technology can exclude some people from an initiative. To talk about one of them, let's use the example of Pesca Data, a mobile app for fishing cooperatives to manage data to get environmental certifications and some other features like connecting them to other fishers. There are lots of different mobile app projects for fishers, so this gives us kind of a case study into this genre of projects. A key goal of Pesca Data is to provide services to small and underserved fishing cooperatives. However, somewhat paradoxically, serving the most underserved fishing cooperatives is hard to do with a mobile app, precisely because these most marginalized fishers often have the biggest barriers for using technology. For example, many of the fishers had difficulties using the app stemming from mixed formal education levels and literacy barriers, and these barriers tend to fall along generational lines as well as gender lines. Additionally, a pretty common access challenge for these fishing mobile app projects is that there just is not good cellular connectivity at sea, and that limits who and how people can use them. More details on this work will be available soon in a forthcoming publication from anthropologist Claudia Delgado Ramirez. So what can you do about these technology access barriers if you have a mobile app project? One is to center the most marginalized users in your design process. When you design specifically with the people who will have the most trouble using your app, then your other users will also tend to benefit as well. Another is to use diverse methods and communication channels. Expect that some people will want to use your app and others won't. So you can use a multi-pronged strategy to meet people where they are. And in some circumstances, it can help to invest in training for an app. So another example I want to quickly point out is exclusion from online spaces. In Claudia's work on pesca data and fishing cooperatives, she found that lots of fishers had lively Facebook and WhatsApp groups, but they were largely gendered for only men or only women. I also have a paper coming out soon where I interviewed staff of environmental organizations about community engagement, and they identified social stigma as one of the main barriers. For example, in some organizations where there were mixed languages, non-English speakers stopped participating in group chats because they felt excluded. And sometimes these problems are addressable with careful design and moderation, but sometimes they're just not. This is just another example of how relying on technology can sometimes unintentionally exclude people from environmental initiatives. So now let's move on to the last topic for today, AI model biases. This is going to become really important soon as we start to see more and more uses of AI in ocean governance. There are a lot of different types of AI that all have different but related problems. So to introduce the problem, I want to start with an example of AI language models like ChatGPT. What does ChatGPT have to do with ocean governance, you might ask? It turns out, talking to people at the UN, that policymakers are already using ChatGPT for all kinds of things, like drafting statements on things and doing background research. There are already commercial products on the market today that use AI language models for different types of policy analysis. To give you an example of this slide shows a screenshot from OpenAI's GPT store, which is kind of like an app store for different custom versions of ChatGPT. A couple days ago, I did the search for environmental policy, and you can see that there are already all these different AI agents specialized for talking about environmental policy on the GPT store. So people are already building these for environmental policy and already using them. And also, the tech industry is investing really heavily into AI language models, and we expect to see generative AI coming into more and more parts of the policymaking process. It'll probably change the way that policymakers do some of their day-to-day work, similarly to how the internet or how word processing software changed the work of policymaking. So it is obvious to see how this might cause some problems, like AI language models have biases. Just to show you an example, if we ask ChatGPT, does the USA violate human rights? It replies, the question of whether the United States violates human rights is complex and subjective. And then it goes on to give this kind of rambly, non-committal answer about how perspectives on human rights can vary, blah, blah. However, if we ask almost the same question, we ask, does Thailand violate human rights? It is quick to answer that yes, Thailand has faced scrutiny and criticism regarding human rights issues, and it goes on to list all these bad things that Thailand has done. So we can see that GPT has biases that can become problematic if it is being used in international policy. So to dig into this further, we made a chatbot about the UN Biodiversity Beyond National Jurisdiction Agreement, similar to these sorts of agents in the GPT store I just showed you. And we tested it out to examine AI language models' strengths, weaknesses, and equity problems for use in marine policy. You can find the preprint on arXiv. Here's the link on the slide. In the paper, we examine ways that AI language models could be helpful for some of the specific tedious parts of policy work, especially for smaller governments. Of course, though, we have some big concerns. In the paper, we elaborate different causes of errors and biases in our BBNJ chatbot, including biases in GPT itself, which it learned from being trained on biased text from the internet, newspapers, and books, biases from its connection to the BBNJ negotiation documents, which tend to overrepresent the viewpoints of the developed countries, and biases stemming from the application design. Still, in spite of this, we expect that generative AI is going to creep further and further into policymaking processes, and it's going to become important for people to develop more AI literacy to be able to get the most out of it while avoiding its pitfalls. So we've developed a workshop on ChatGPT for policymaking practitioners. We presented it once with the Ocean Voices Fellows, and I'm really keen to present this to more groups. So please get in touch, reach out if you're interested in doing a workshop like this with your group. We're also finishing up a website with all the material, so keep an eye out for that as we'll launch it in the next few weeks. So let's turn our attention to another AI application, computer vision. And for those who don't know, computer vision is essentially a type of AI where a program tries to understand what's going on in an image. Like one example is how social media apps automatically try to identify faces in pictures you upload. It essentially still works by training a model with lots of example pictures. And we're right on the cusp of computer vision becoming much more widespread in ocean management pretty soon. And this is because the technology pretty recently became good enough to start being useful. So there are lots of different applications in early stage development that seem to be getting promising results. For example, there are projects using computer vision to identify and count fish underwater as they go into a net with cameras mounted on the net. Projects to monitor onboard fishing boats, identifying and counting all the fish that get caught or what fish get thrown overboard, often also predicting the fish's sex and age, and also lots of different applications using computer vision with satellite images, like trying to identify the locations of fishing boats. The bias issues with these vision models are a little different from language models, but still related. They will make errors sometimes, and the errors won't always be evenly distributed, possibly behaving unfairly to some people. And since these uses of computer vision are also new, we will likely need a lot of research into their equity, fairness, and accountability. Researchers are still trying to figure out methods for evaluating computer vision models, especially their equity and fairness aspects. It's pretty new territory, and this is the direction that we'll be working on in the future. This will become really important soon as we see more and more computer vision in ocean governance. Fortunately, there is research in other sectors that we can build on as we figure this out, like critical technology research, algorithmic fairness, technology policy, etc. So this is the end of my slides. Again, I'm not saying that ocean technologies are bad or that we shouldn't do them, but it's really important to have these conversations about equity. We can learn a lot from the hard-fought lessons in other technology sectors, hopefully avoid some of the mistakes, and strive to design ocean technology that is fair and equitable for everyone. So now I'll hand it over to Richard Anderson for his remarks.
So thank you very much, Matt. This is fantastic work that you've been doing, and I'm very proud to see my student making these fantastic contributions. So one of the critical things that you're raising is how is this technology going to be designed and implemented in an equitable way? And as I see it, there's this really deep problem that technology is being developed in San Francisco and Seattle, and for many, many economic, cultural, historical reasons, it's centered in a small number of global tech hubs, and dissemination is top-down and uneven. So the really deep challenge I see is how to change this and how to move forward on a different path. And one of the things I've been thinking about very carefully recently is how is global technology capacity going to evolve over the next, let's say, decade, so that the future AI applications are developed globally by local talent to address local problems. And for example, in the ChatGPT applications that you were talking about, there are all sorts of inherent biases that come up from where the where the technology is developed, where the data comes from. And there's also a whole set of opportunities of how this will be changed. So there are a set of open source technologies that have the potential to undercut some of the technology monopolies, allowing more of a bottom-up process in development. And similarly, around the design of these applications and implementation, looking at large language models, there's a separation between kind of the core engine and how it's used as an intermediate level. And this is one of the opportunities I see for building capacity so that tools can come up globally and be more applicable. But one of the things that's very clear is these tools are going to be widely used and are going to be adopted. And so how are they going to be directed appropriately to adjust balance? So I guess I'd kind of like your response to this issue. So I should put Matt on the floor for.
The question is, what's the question?
So the question is supporting appropriate design of technology done by local technologists as opposed to the model of kind of developed globally and sent top down.
Okay, I think there are a few key challenges, and some of them you already talked about, where one is just kind of developing local capacity for people to build their own technologies instead of being kind of consumers of what comes out of Silicon Valley. And in particular with these new AI things we're starting to see, there is this situation where you kind of a lot of the new AI stuff is using these things called foundation models, which is just a huge model trained on, in the case of ChatGPT, just like all the text on the internet. So it's just this big model kind of trying to understand the world and being able to talk. And then you take this big model and like adapt it a little bit for whatever thing you're trying to do, like make a environmental policy chatbot. You take this big thing that somebody already made and somebody already controls and change it a little bit at the end for your work. And in kind of the newer computer vision stuff is sort of the same process where people make just a huge model of tons of images just to give the computer this sort of ability to like understand what's happening in an image. And now you take this big thing that somebody else made and controls and change it a little bit to kind of do the thing you're trying to do. So part of the right now, the biggest models like GPT is it's owned by this company called OpenAI. Nobody else, they're not, very open about how it works. They're letting other people see the insides of it. So this, there's a lot of work on kind of developing alternatives where people have more control over these big foundational models. And I think this is going to be important for addressing some of the issues with biases. So there's kind of two things. One is kind of developing technical capacity for people to build the technologies they want to build instead of having to follow like Silicon Valley's rules. And then the second thing is that there are changes in the technology itself, like using a different way of doing foundational models, or making them open source, for example, or developing better tools to make it easier for people to do their own things.
Richard, can I?
Yeah.
I'm sitting here. Can I just come in and then ask questions? So you've been working on computer science and public health, and surely this disparity in terms of the access. A little closer. Okay, disparity in terms of access in the public health is huge. You see between North and South, or even in the COVID, we actually see the quite strong racial biases and some of the cultural marginalized people have been suffered quite a bit. It's really because of not just only the service, access to the service, but really their opinions and understanding has been prevented because of the historical path. Surely the people like you who believes in equity has really trying to stop that kind of biases to come in, or has trying to make this computer tool much more useful to service equitably for those things. Is there any technique or any conversation or anything the public health sectors have achieved and tried, and perhaps we can actually learn from it and apply to the ocean governance? Is there anything?
Yes, so this is a fantastic point to make. And one of the reasons I was actually excited to see Matt making the leap from computer science to the ocean governance area, because one of the things that's happened in computing and global health is there was an initial phase of technology push, primarily from the Western countries globally. And one of the things over time, very important lessons about professionalization of these technologies, a progress of making the technologies more mature, a problem of making the technologies deeper owned by countries. So a tighter ownership, involvement, local leadership. And this is a process, maybe 20 years of work.
Right.
It's kind of 2 steps forwards, 1 step back. But the process of having the technology in global health mature and become embedded in systems has been slow, but important. And these are the lessons that I would like to see transferred just to speed the process of appropriate technology being available and used in different domains.
In common narratives, we tend to fear there's AI and the language model development has really trying to get rid of those workforce who really takes care of you physically, really approach you like as a human, and passing all to chat box or, computer generated answers, that's what I'm afraid of, and that's what people are afraid of. What do you guys see about this?
Do you have a quick take?
So yes, I've got 2 somewhat contradictory takes on this. One is just of complete fear and displacement.
Yes.
But a reaction is there is a subset of these technologies that can be really, really useful for making things more efficient. And being able to automate some of the simple things will just help people at the personal level. And so when used appropriately, and when these technologies can be directed at social goals as opposed to furtherance of a technology monopoly, they can be incredibly valuable. But this requires a certain amount of governance, as well as the ability for local control and management and understanding of the technology.
Right. Excellent. Thank you so much. So we have our brilliant organizer, Ariel Wong, and also Karen Otsuka has been collecting questions from you. So Ariel was going to read out, and Richard can answer it.
I can pull up this Q&A slide.
Yeah, it's all right. I think it should be you and Richard still facing it. Yeah, come down this way.
Hi, everyone.
Be out of the break.
Hi, Matt, Richard, Yoshi. Thank you so much for your conversation. It was so exciting. And so thank you for logging on today. I'm Ariel, the communications lead here at Ocean Nexus. I'm excited to read the questions. So feel free to drop them in the chat or in the comment box. Okay, great. We have one from Elaine Shen. What kinds of federal governance mechanisms might help incorporate equity into public-private partnerships. All right.
Do you have a thought? I have, so the reaching for an answer. I mean, so the technology industry has been really good at avoiding regulation, I think because partially because things are changing so fast, but other reasons too. And that makes this a really hard question for, it's a little bit different for each type of technology, but there is a lot of work. So, people trying to figure out how do you regulate AI right now. And there's work on requiring disclosures about what models are trained on, what data goes into them. There are, talking more generally about other technologies, there is kind of models to look towards in a bunch of different countries around the world have passed rules requiring that data generated on their citizens needs to stay in their country instead of being exported to servers in the USA, for example. There is the EU has been pretty proactive in terms of things like the GDPR regulating privacy, who can keep whose information for how long. So that's I don't know if that's do you have something to add?
So yes, one thing to add is that various forms of competition can be very important in mitigating problems. And competition, when it emerges that there are multiple platforms available, where there are choices available for people and different implementation environments, that there are a lot of opportunities that emerge when there are widely available open source platforms that can be utilized in technology development.
Great. Next.
Great. Thank you for your answer. We don't have another question right now, so I've prepared one just for this kind of scenario. So during your presentation, you discussed how AI technologies such as computer vision applications have similar but different biases and equity concerns as ChatGPT. Can you tell us a little bit more about how these computer vision model biases, where they come from, what they are, and how are they really different from language models? They're right there.
Okay. This is great. This is something I wanted to talk about more in the presentation is so to explain what I'm talking about is I kind of want to refer to at the World Fisheries Congress about a month ago. I saw probably like, I don't know, 15 or 20 different presentations, maybe a little bit less, about all of these different types of really different things people are trying to do with computer vision now. For example, putting cameras in the ocean just to see what kind of fish swim by and identifying what they are, to different things for compliance, putting cameras on boats and watching for what comes down the conveyor belt, to things like sorting shrimp on size by taking pictures of them. And to right now, the sort of way that these models tend to work in computer vision, the state of the art is that they're really specific to whatever thing you're trying to do right now. Where to create one of these models, say for like if you're making a shrimp sorter, you have to sit down and label thousands of pictures of shrimp in terms of what grade they are. And then you show them to this model, and now it's good at seeing a new picture it hasn't seen before and guessing what grade of shrimp it is. But and you can get pretty good results on that, and it'll work pretty well. Kind of with the state of the art today. But the problems arise from these models tend not to be very generalizable. Like you can't take this shrimp sorter model you made in one place and now take it to another place where the shrimp look different or the conveyor belt looks different, and it's not going to work as well. So there is, given that it's a lot of work to produce these models, it is, and they don't generalize well. like that, I think, is kind of one of the places where biases are going to arise. So say if you have you're trying to use an AI thing to look for bad behavior on fishing boats from cameras people have mounted in different places. Now, all the fishing boats are different. They are all operating in different places where the fish are all different. So it's like, do you train a model of like, here's 1,000 pictures of things we labeled on this one boat and build a whole new one for every boat? Like, it's just going to be too expensive and too impractical. So people are going to try to build a whole thing that generalizes across like all the boats in this whole country or all the different types of boats. And this is where some of the problems are going to arise, is like they're going to tend to make mistakes, and the mistakes that they make is going to depend on like who fed what data into them, who kind of took the trouble to label all of the data, hire all the technical expertise. Like that's so there's a lot of issues of like control over how this is going to be implemented and rolled out at bigger scale.
Great, thank you. All right, now we have 5 more questions. I'm going to go in chronological order.
Okay.
From Brian, I liked your comments there, Richard. One thing I have seen in environmental sectors is that the answer to using AI for social goals will be market strategies, market-based initiatives, etc. How do you and Matt see the role of the state in all this? When markets are unreliable, I'm concerned because we already see an inability to regulate tech sector.
So this is certainly a challenging question to answer, because there certainly are a lot of market opportunities, and markets can address a lot of problems, but simultaneously, create a lot of other problems. And AI governance, has a whole set of unique challenges, because a lot of AI governance is trying to govern things that are not fully understood.
So how do you do it? How do you govern it? The approaches that I'm seeing now is people, I already kind of mentioned this, are requiring disclosures about like what happens in this model, what data was fed into it. But there's still there's still like a lot of research we need to do figuring out how to evaluate these things and understand what the biases are. So it's a hard question.
But I think there's just this tremendous thing that's happened of trying to play catch up to technology that's already out the door, that we're trying to figure out what has happened with these technologies.
There are a couple people I could refer you to. There is this a group doing really good work on this called the Algorithmic Justice League. And then here at the University of Washington, we have a tech policy lab that are thinking about these questions pretty deeply.
Thank you, Matt and Richard. So next question from Alessandra. What kind of process would you implement to make sure that the technology is inclusive for all communities? Process.
There's I think one of the most important things to talk about is decision-making power. I really liked using that word. There's kind of in sectors like global health, there have been a lot of this word like participation and participatory, but a lot of the times these processes have ended up being kind of tokenistic, where it's like somebody like me shows up in somewhere like rural Kenya, and where there's a big, and here are all these technologies that I've developed in Seattle, and here's what you should do. And then there's the participatory processes are like really not good enough. They kind of technologists still have the decision-making power. So how do you actually do this in practice is one, there's a certain amount of capacity building that you need to do to kind of make sure that your partners really can take control of the process. I think that the question is a little bit analogous to kind of data and research. Yeah, okay.
No.
Okay.
No.
I was just going to say there is a resource on the Ocean Nexus Learning Forum from Arabise and Chris Rothschild about designing like data and research initiatives with communities. And I think that that's kind of analogous. I would recommend checking that out.
Great. It's called D4D, Data for Decision Making, and we have Ariel, can you?
Yeah, I'll drop it here.
Thank you.
So one point I want to add in response to the question is very often there's opportunities for making technologies more inclusive without making them perfectly inclusive. So the examples that Matt gave earlier in his talk about mobile apps being able to reach a lot of people, and if you have a communication technology, you can optimize for smartphones. It's brilliant if you also optimize for basic phones. So it's targeting a range of technology. And I think it's more having the philosophy of trying to maximize and increase inclusion as opposed to immediately making perfect inclusion.
Can I just jump on? I mean, often
Yes.
those often the people come in where they're not asking for the help. I think that will be a problem. I see this video sometimes in the documentary for the fisheries management, which is perfect logbook taken by the local fishing co-op. And there's this guy came up and he said like, hey, now you don't need this, you can use this. And I thought like, no, don't touch it. If it's working, there's lots of things going on.
If it's work, don't.
Yeah, if it's
Don't
working,
fix it.
right, don't fix it. I mean, that's what I think. And often there's kind of like a, the desire for the people to bring in a project, and then not for the community itself, but for somebody who wants to market it, wants to sell it, wants to make some kind of like techno-optimistic things. I mean, that part needs to be really well discussed, and surely the people in the community wants to have a technology, but it's not necessarily necessary at some point, which people come in and try to sell it.
And so I guess I'm going to respond to just a set of questions that have come up in one of your original points about how this relates to global health. So the history of computing in global health, maybe 10, 15 years ago, there was a recognition of all of these small projects coming in, achieving nothing. Uganda had a very famous moratorium on mHealth projects, which basically said, stop this until we figure out better management and have some type of assessment of all of these things going on, as opposed to a bunch of random tech projects. And I think that gets back to some of the questions relating to tech governance, that responsible oversight.
Thank you. Sorry to barge in. Ariel, please continue.
Great, thank you. Okay, so we have a question from Vicky Honda. Hi, Vicky. And in regards, I think, to a comment and question based on Elaine Shen's question, which was what kinds of federal governance mechanisms might help incorporate equity into public-private partnerships. And her question is, thank you for taking up this very important question. What can donors do or specify when they fund a project to make sure that the research is using equitable information tools? So good.
So donors certainly do have an advantage when they're doing these types of things of providing the money, and people will certainly listen to donors in a special way. So it is making sure that when the donor is giving requirements, that they're realistic in the implementation. Two, that they're verifiable so that you can't just say, yes, yes, take the money and ignore it. And also that they're well understood by both the donor and the party receiving the money and the community that is being involved in the project.
Something a little speculative that I'd like to add is that there are, so there's this thing called the digital development principles, which was sort of set up to address a little bit different problem, mainly of just lots of wasted money on tech projects that didn't work. So kind of all of these big organizations came together and they agreed on this sort of set of principles that are mostly things that are kind of obvious, but projects fail all the time because they don't do it. Like think of security, use things that already exist instead of building your own thing. And this has become kind of important for evaluating donors evaluating technology projects in some sectors. And I think maybe we're due for a similar sort of tool for thinking about equity.
Yes, I really think that this can be adapted and expanded on in this domain. And there is a lot of very good work that's been done in trying to design guidelines to make these projects more responsible.
Great, thank you. So our next question from Andres. Are there any technologies that you see a lot of specific potential for in terms of facilitating less extractive ways of recognizing and integrating Fisher's knowledge in management?
No.
Yes.
Nothing is immediately coming to mind. I don't know. Do you have a take?
No, I do not have a take.
One thing that I will say is that what I am hopeful for is more sort of bottom up approaches. Like I think that is what we need. Like the ability for Fishers to, for it to be easy and people to understand how to make your own AI thing, to do whatever you want to do instead of depending on like an NGO or somebody else for it, or build your own mobile app, or like I think the more that the tech industry can, and not only, we shouldn't ask the tech industry to do it because they won't, but like the more it can be, people are able to kind of take control of technology for themselves and do what they want with it. I think that is, the more we'll be able to see people like Fishers kind of express what they want to and do what they want to do with it.
Great. Anything else to add? Thank you. So a final question. Here we have from Brett N. I would love to hear your thoughts on data ownership. I have been rejected from accessing researchers' data since they used their grant money to collect the data and wish to continue to exclusively publish on it. I've also been unable to use other data due to copyright on data. How can we incentivize / enforce researchers and companies to make data readily available?
Do you have a take? I could say
so this is very, very complicated. In that I see kind of two contradictory things at play. So one, that for publicly funded research, that it certainly feels that after an appropriate period of time, data must be made available for reproducibility and for other people to build on top of it. That I find in a lot of projects that I have been involved in, that there are third parties or governments which legitimately do have data ownership concerns, and they have the opposite worry of people exploiting their data without their control.
Can I come in?
Yeah.
So, hi. So, quite a few years ago, I created this data set, not me, Andres, you did it. Created data set of the seafood consumption with indigenous, coastal indigenous peoples, globally. So what we did was, we picked up every single documents in ethnography and everything, just find any evidence of any of the coastal indigenous people self-claim, recognize, as wide as we can, how much of the seafood they are consuming. And we created this, big Excel sheet. And we wanted people to use, and it's openly available. And there's two things. One, okay, it's very imperfect. It's really wrong to put those in numbers. And politically speaking, it can be used against the people we wanted to support. Our initial intention was really for the people to recognize, yes, there's still the coastal people eating seafood. It's very important. And some people say, like, is it, the food consumption behavior has changed, it's being westernized and all that. And then we just have to say, look, that's not true. It's right there. So, but this can be used by someone who has different intentions. So it's really difficult to some extent that, the data itself matches with the or use of the data matches with the intention of the person who created. And then also we cannot really be so responsible holding this information all the time and update it. So I think it's a really difficult question that you ask, but I believe to the extent that data should be used openly most of the time, and this discussion should be happening all the time. And as long as that part should be secured between the original creator and a new author or researcher, I think it's a better use of the data, really. When that breaks and when people just do whatever, I think that will be the issue.
Yes, but I find there's always this fundamental challenge of when data is coming from people or using people's behavioral data in some way. The question of individual autonomy over data, or the question of national organizational autonomy over data conflicts with the ideal scientific notion of doing things completely open. And I certainly do see that, from the scientific perspective, we really want to be extractive of other people's data. And
and then I have
it's
to
complicated.
Say, I have to say, when the research or any of the discussion and topics that concerns equity, we usually do not find data. We have to often create from the scratch. So I think that's a really important point, that we have to assume those inequity which emerges in any sector that is usually not available as data. That's one thing we really need to think about it before people start looking into it and trying to extract from themselves.
And there's also just looking at inequity, there's naturally going to be issues of getting data from the marginalized. And often that is not handled in a fair and just manner.
Yes. Yeah, good question. Thank you.
We do not have any remaining questions. We do have 3 more minutes left. So closing remarks, next page.
First, I want to thank Richard and Matt. Thank you.
Yay, thank you. Yeah, thank you. Okay, well, thank you for joining us on our first Kickoff Ocean Equity Learning Forum webinar series. If you're interested, please sign up for our newsletter. Here's the QR code. I'll drop in the link shortly. Our next conversation will be on the topic of marine conservation. What exactly? It'll be about high seas marine protected areas, so MPA and the BBNJ Treaty. So how do we do MPAs in the high seas? Find out more. sign up for newsletter. Also, all this information will be on the same exact page that you found this webinar, so oceannexus.org/webinar. And then you can go to the next. If you're really curious, you can learn about the context. So as a part of the Ocean Equity Learning Forum campaign, we have a specific page dedicated to all of marine conservation research that Ocean Nexus has done. You can do your QR code here and go directly to the marine conservation portion of our Ocean Equity Learning Forum. And thank you so much for logging in today and being at our webinar. We'll absolutely have this online, ready for anyone to view and download. Yeah, you want to pop in?
Okay.
Thank you.
Thank you so much.
Right. Thank you so much. Thanks, Richard. Thanks, Matt. Thanks, Ariel.
Yeah, thank you.